We've been working with these hyperbolic trig functions for a little while now. We haven't done any calculus yet. So now we're going to start doing calculus with the hyperbolic trig functions. And what I want to start out with is just calculating the derivative of sinh of x. Now, one thing that's nice about the hyperbolic trig functions is we've built them out of functions that we already know the derivatives of. So I don't need to worry about going all the way back to the limit definition. I can simply rewrite sinh as e to the x minus e to the negative x over 2. Now, some of you might see that and think quotient rule, and quotient rule isn't wrong, but it's not very efficient here because the denominator here is just a constant. So I'm going to just factor that out and use the constant multiple rule. This is the derivative of half of e to the x minus e to the negative x. So, using the constant multiple rule, I'm going to get half of the derivative of e to the x is just e to the x minus the derivative of e to the negative x. That's going to be a chain rule because that's a function composition. So that's going to be e to the negative x times the derivative of negative x. Okay. That's an easy composition to miss because we often think compositions have to look really complicated, but it's a composition if the input is anything more complicated than just x. All right, so that's 1/2 of e to the x minus e to the negative x. That would be a -1. I'm just going to combine that with that negative sign to change that to a plus. And then I think I'm going to slide that 2 onto the bottom and write this as e to the x plus e to the negative x over 2. That's a familiar formula. That's cosh. So the derivative of sinh is cosh. Okay. Now, in the homework, you're going to be deriving the other 5 derivatives. Okay? It's an even-numbered problem, but it's an important one, so I've assigned it. And there are solutions posted because A, it's even numbered, but more importantly, because you can just look up the derivatives, they're given in the body of the text. More importantly, it's a derivation, so you can sort of look through the work. I want to just point out a couple of things. For cosh, you're going to need to write cosh this way and take the derivative. It's very similar to sinh. But once you get to the others, it's not necessary to write them in terms of e to the x. You could, but if I'm taking the derivative of tanh x, I've got 2 options here. I can say that's the derivative of sinh over cosh, or I can say that's the derivative of e to the x minus e to the negative x over e to the x plus e to the negative x. That looks simpler. So if you do the derivative of cosh first, by the time you're taking the derivative of tanh, you know the derivative of sinh and cosh, you'll need quotient rule, but you can just use that description of tanh. Same thing with cotanh, although it's just going to be flipped. And I'll also point out that when you get to the derivative of sinh and cosech, sinh is the reciprocal of cosh. Now, when we were working with regular trig, and we were doing the derivative of secant, we had to write it as the reciprocal of cosine and use quotient rule because we didn't yet know chain rule. Here, it would be perfectly acceptable to use quotient rule, but I probably wouldn't because the top now is a constant. I could rewrite this instead as the derivative of cosh x to the -1 power. Now that's the 1 power that you must write it this way. You cannot write the -1 there. That would be interpreted as an inverse sign. So when we're working with functions, and same thing is true with trig, I can write sine squared x. I can't write sine to the -1x this way. That means inverse. That's an inverse sign, not an exponent. Okay? Same thing is true for the hyperbolic trig. So I would have to write it as cosh x in parentheses to the -1, but then I could use chain rule rather than quotient rule. So it's up to you which method you prefer to use. I think the chain rule goes a little bit faster. Now, that's homework problem 24 in your text. If you want to complete that before watching the next video, totally fine. Okay. In the next video, I'm going to have the formulas for all 6 derivatives up on the board. Okay. Just so we can talk a little bit about the patterns that we see and how to remember those derivatives, because you are going to want to know them as well as be able to derive them. Okay. Now, if you don't feel like doing homework problem 24 now, it's fine. By the time you do it, you'll know what the answer should be, but that's not a big deal. You should still work through deriving them. I could ask you to do that on an exam or a quiz, but I'm also going to expect you to know them. And again, that's important because later on this semester, we'll be taking a look at, here's a function, what is it the derivative of? And if you don't know those formulas, it's very hard to reverse that process.